Hello everyone and welcome to this Cambridge International Conference workshop session. My name is Jessica Mooney and I am an Education Manager in the Teaching and Learning team. Today I'm joined by Tim Oates, who is the Group Director of ARD, our Assessment Research Division. Our theme for the conference this time is metacognition, and today Tim will be talking about the link between thinking and language, which is of interest to us obviously as an international organisation, but also because of the importance we wish to place on learners achieving their potential and developing both their language and literacy skills. As my colleague James said, there will be an opportunity for you to ask questions, so please do pop your questions into the chat box. We will come to those at the end and we'll try and answer as many of those as we possibly can. Any questions that are not answered within the chat today can be carried forward into our other workshops and we can try and address those there. So I will hand over now to Tim. Thank you so much, Tim.
Well, thanks indeed, Jessica, and thanks very much indeed for the invitation to present today. I really welcome the chance to talk through this really key topic. So thanks. I'll talk for about 40-45 minutes, and hopefully that will leave enough time for questions. Now, this is an interesting area. There is plenty of work on it, stretching back a very, very long time, back to the pre-Eleatic Greek philosophers. But a lot has become possible recently in terms of empirical work on the brain. Now, the French linguistic philosophers, people like Jacques Derrida, did very, very interesting work, conceptual work essentially, on the idea of the relationship between language and thought. And this idea of metacognition, which I think we can define as thinking about thinking, can draw on Derrida's work. He spoke about the idea of language making thought visible, that it objectifies our thinking. In other words, we have thoughts, we articulate them in the form of language, then they become an object about which we can think. Now, a lot of this work was done in the absence of understanding much about brain structure, and that's where really the last 25 years of empirical work on the structure of the brain enables us to link this more philosophical work on language to the realities of how children learn and the realities of why certain adults can't achieve higher levels of thought and metacognition. And that's really what I'm going to do today, is take us through the way in which language and thinking link and the causal relationship between the two. In what way does language play a role in thinking? And in what way does a focus on literacy and language support higher order thinking, which is a key educational question. Now, I've just picked 4 questions which are typically being discussed at the moment in our own world around assessment. We've got a question of whether you can improve access to assessment. This is not the 4 things up here. This is a separate set of questions, and it's fine. I'll just deal with these 4 things, and then I'll come on to these 4 things on the screen. We're often asked, can we improve access to assessment by removing complex language? And that's something which the national regulator in England is actually looking at. So if you've got quite a simple maths problem in terms of the maths construct, if you wrap it around with complex language, does it prevent you from measuring the mathematics attainment accurately? The answer is it does, but we have seen assessments where the accessibility argument has been taken too far and removes the complex language, which is actually part of the discipline, whether that's mathematics or science or English literature or history. You can go too far in making language simple within an assessment. That's the first question. Second question, what literacy demand should we have on young children? How complex should the language be that we expose young children to? Thirdly, when should we start children reading? Now that's been very complex and contentious when we compare different national systems. Done a lot of work in Finland, very misunderstood Finland, and lots of American comment on outlets like Huffington Post. Well, kids in Finland don't learn to read until they get to school. They don't go to school until they're age 7, so we don't need to bother about early reading. None of that's true. It's not true about Finland, and it's not true about what we should be doing with young people. Fourthly, how should we encourage complex critical thinking in education? Now that, on this whole skills knowledge false opposition, there's a great deal of discussion about the importance of encouraging high-level complex critical thinking in education. And what I'm going to do today is talk through the extent to which language and basic literacy acquisition really plays a role in giving young people and young adults access to high-order critical thinking. And as part of that, metacognition, how we turn our own thoughts into an object for scrutiny, how we can think about our own thinking. And articulating how we are thinking in words, describing it, is a really important part of that. And I think that will become clear as I go through the presentation. Now, there are some repeat slides in here, and that's very deliberate, because I'm going to return to the work of Kurt Fischer. Kurt Fischer's work is very important. It is heavily based on empirical work on the structure of the brain and the impact on brain excitation of external stimuli. It's really how we interact with the world through our cognitive processes, but having been explored through work which involves active brain scanning, so we know how the brain is functioning as the activity is actually undertaken. It's really very powerful work, but we can represent it quite simply, and he has done so in a couple of key papers. And I will repeat a key diagram which I sort of want you to have fixed in your minds going forward. So those are the sort of typical 4 questions in educational philosophy and educational debate at the moment. Some of them quite philosophical, some of them very practical. Now the presentation will cover these 4 things, these 4 different things. Does language develop independently of development of thought? And you will see that, in a sense, that's a rhetorical question. Absolutely not, but they stand in quite a complex relationship to each other. That's what I will explore. Secondly, what's been happening in the acquisition of language and to literacy in general? And not a good picture here, actually, internationally. Quite worrying. A lot of talk about wanting to have education encourage young people to engage in higher-order critical thinking, but unfortunately, not enough attention to the acquisition of basic literacy, which is a prerequisite, I'm going to argue, to higher order thinking. And as part of that, is it true that precision in language is precision in thought? I'm going to say yes, and I'll argue that, hopefully with some precision. Fourthly, is exposure to certain forms of language essential for attainment and higher order thinking? And there I'm going to look very much at the work of the late Jane Mellanby, who had a long and distinguished career in Oxford, who died last year, and I had the great privilege of working with for a number of years. And she and Julia Badger did very important work in relationship to what kind of language forms young children are exposed to, and how this relates to cognitive development and educational progression. So that's the shape of the presentation. Right, next slide, please. Thank you. So, does language develop independently of thought? And I think Pawlowski and Sakai's work is really fundamental in understanding this. Again, very good work based on the latest empirical cognitive science. And so this is a question that they ask, and then they answer. Why do children acquire language by the age of 6, while taking a lifetime to acquire cognition? And the work of Fischer, which I'll go on to in a moment, really explains why. So what we need to see is this kind of stuff that Derrida was playing with in France about 100 years ago. Language is created by the mind, yet once uttered, words return to the mind. In other words, Derrida described this as objectification of thinking. I think we've all said something which we watch the reaction of others, or we considered what we said and say, oh no, that's what I said, but it isn't what I meant. Now, that's not just a simple phrase. Language is used to represent thought. And once we say what we think, we can look at what we're thinking. And we can look at the correspondence between what we've said and what we think. This is really fundamental to this area, and it gives us deep insight into the causal relationship between language and thought. So we create things in a linguistic form in our mind prior to a speech act. We then make the speech act, but then it returns to the mind, where we consider it. So language is created by the mind, yet once uttered, words return to the mind, where they're understood, both by ourselves and others. The cycles from the mind to language, and then for the language back to the mind, is recursive, in that the language produced by the mind comes back to the mind once again. The functions of language are part of the brain system at the same time as being involved in the workings of the mind. So we can see this dynamic and dialectical relationship between language and thought. They're really, really interwoven. And then we return to that question, why do they acquire language by the age of 6? While taking a lifetime to acquire cognition? Well, the fact is, you may acquire the underpinning generative grammar, Chomsky's work, by the age of 6, but as you begin to extend vocabulary and relate different terms which actually delineate contexts one with another, you then enhance your cognition, and that is indeed a lifetime's experience. So we don't finish acquiring language by the age of 6, we acquire its grammar and its structure. And then we constantly elaborate it, whether we're a poet or a scientist, looking at increasingly fine and elaborated distinctions between things. And that's what I'll now turn to. So next slide, please. So Pawlowski actually has a lovely phrase, which is, events that are not described in language are likely not even to be recognized in cognition, not even noticed or perceived. It's very important that the way in which we perceive the world is linguistically mediated. Now, I'm going to show how concepts relate to words. This is a very common confusion amongst young children understanding science, the difference between diffusion and diffraction. They are very, very different, but look, they have the same initial root in the word. And so they're easy to confuse, but they're incredibly distinctive. So if you're both thinking about something and you are communicating with others, maintaining the distinction between these two words is actually very, very important. You will not be clear in your own thinking, and you will not be clear in what you're communicating if you confuse the two. Diffusion is the intermingling of substances by the natural movement of their particles. If you drop a single drop of ink into some water, you will see it disperse. It will diffuse through the water until it reaches a state where the ink is evenly distributed in the water. That's a process of diffusion. Diffraction is actually fundamentally completely different. It's the bending of waves around corners of an obstacle, or through an aperture into the region of geometric shadow of the obstacle or the aperture. So it's essentially, it's the bending of light. The diffracting object or aperture effectively becomes a secondary source of the propagating wave. Bit of a mouthful, but diffraction is essentially when you bend waves, whether they're sound or light. They're fundamentally different, but they're often confused because of the similarity between the linguistic form of the two words. But for clarity, you need to understand the difference. Now, you probably have heard in English the two words uninterested and disinterested. Now, if I'm uninterested in something, I lack interest in it. If I'm disinterested in something, it is that I don't have a motive for benefiting from it. Fundamentally different and constantly confused. But so different that if you say, I am disinterested in this matter, and you simply mean you're uninterested, you're communicating something very different from saying, I'm disinterested in this matter, and therefore my opinion can be trusted. I know a lot about it, but I am independent in respect of talking about this. Now, look, we're really beginning to explore the relationship between thought and language, and precision in language being critical. Next slide, please. So to show you, you may be doubting this phrase on the previous slide, that something present in language affects our cognition, and something not present in language may not be seen or recognized. But we can immediately gain some insight into this by looking at the history of science. Now, Lavoisier and a number of English and French scientists explored burning, how things burn. And at the time, the idea of chemical combination, oxidation, that things react with oxygen, and the burning is facilitated by the provision of oxygen, was not understood. That mechanism was not understood at all. But there was a word for what they thought was happening in burning. They thought that anything which burned gave off a gas. That everything that burned gave off the same gas, and that gas was called phlogiston. And look, you can see it because, of course, when things burn, you can see it burning. So it must exist. So it's completely wrong, but it was given a term, and it affected the cognition of scientists because they genuinely believed that phlogiston was a real thing. So the language affected the way they saw the world, with a lot of confirmation bias. Because that word existed, they thought that the gas, phlogiston, existed. Now again, we're really exploring the relationship between language and thought and reality. Very, very interesting. Now, essentially, most of what we want to do in education is about the apprehension of deeper structures beneath surface reality, whether that's in history or in chemistry or biology or physics. It's most obvious in sciences like physics, of course. We see the movement of things, the movement of planetary bodies, or the movement of physical objects like billiard balls or ball bearings or a bicycle. And we want to understand the rules that it obeys. We want to understand the deeper structures. We want to understand the fact that we can only see the effects of magnetism. We can only see its effects. We can't see magnetism. We can only see its effects. So we want to understand what the mechanism is of magnets and magnetism. What's their characteristics? So let's just look at three things. Particulate theory, the idea that despite appearances, solid objects have a great deal of space inside them, because the particulate theory tells us that things consist of fundamental particles, bits of hydrogen, bits of carbon held together by forces, but an awful lot of gaps between them. Yeah, this is quite counterintuitive. Most of what we want kids to achieve in school, in terms of thought, is counterintuitive. It's contrary to their lived experience of the world. That's why we send kids to school, to enable them to be with experts who tell them that things are not like they are on the surface. There are deeper things going on. So that's certainly true of particulate theory. But in language, we also have things like, for example, institutional racism. That if we look at a few acts which occur within an organization, whether it be a police service in a country like England or a large corporation, we see a series of incidents, and we can argue on the basis of those incidents that the organization is institutionally racist. Now we have that term, and we see small events, and we think they add up to something structural and important called institutional racism. In a sense, this is exactly the same status as particulate theory. It says beneath the surface of reality there lies a deeper truth. Now we have the term institutional racism now. We did not have that term in 1920. And it conditions our cognition. We now look for things which make us believe that an organization is institutionally racist. And the same is true of economic stability. Even though this may be very worrying, it is certainly believed by many, many economists, and me too, as a social scientist, that economic stability is a construct. It is a term we use. And we then look at economic systems for evidence of whether arrangements are stable or not, whether we're in a period of economic stability. It is inferred. It's not obvious. It's not there on the surface. And goodness me, in 2008, didn't we get it wrong in terms of the global crisis? At that time, bankers and economic commentators were saying, no, we're in times of economic stability. Don't worry about the levels of debt. Don't worry about the nature of the mortgage loans being made in America. No, we're in a period of economic stability. You see, language conditions the way we see reality. That's what I'm emphasizing. Next slide, please. So this is Kurt Fischer's work, and I can immediately relate everything that I've said so far to this. This is really quite brilliant work, and it's predicated on empirical work done with young people and with adults, and looking at their brain excitation when they are tackling certain problems. And Helena Badsi's work tells us there's a huge difference between the working memory and the long-term memory. Long-term memory is huge. We can hold all sorts of millions of memories, but our working memory is extremely small. We can only hold between 3 and some people can hold up to 7 things simultaneously in our working memory in order to work on complex problems. Now, if we haven't learnt something and committed it to working memory, we have to relearn it and put it into our working memory in order to work on the problem. And that's extremely inefficient. If we can put these complex representations of the physical nature of the world, or the nature of social systems, or the nature of into our long-term memory, the idea of metaphor, examples of Shakespeare's use of metaphor, and so on, then we can actually bring them together in our working memory in complex relationships. And what Fischer's work says is that if you look at this single dot, SM4RP1, it is just a memory. You could see it as a fact, but it could be quite complex. It could be something about the world, it could be a word, it's certainly a representation which is fixed in long-term memory. Now, if we bring them into relationship one with another, if we have many of these recollections in our long-term memory, we can bring them together in the form of representations, RP3, which is essentially grids of understandings which enable higher order thinking, by which we can derive insights in our own thought and then restore those in long-term memory. And these go through cycles, developmental cycles, and eventually we end up with very complex internal structures in our long-term memory. The most complex structures, as you can see as we go through these cycles, AB4P1 at the end of the arrows is a complex representation of a state of the external world. They are big abstractions. It could be something like, for example, all of the movement of the planets in the solar system, or if you're an astrophysicist, a really complex map of the movement of celestial bodies beyond the solar system. It could be the structure of DNA and the impact of and the effects of DNA in terms of propagation of the characteristics of living organisms. or it could be systems of power and authority within political arrangements. This is higher order thinking. And from those, you often derive rules. I mean, this is new activity which produces new knowledge. But we can see how it's dependent on single primary understandings of basic concepts and facts. Unless you have those, then you can't put together these complex grids which represent critical and higher order thinking. Next slide, please. For me, as a 63-year-old coming on 64, I find this extraordinarily reassuring. Piaget, of course, posited a whole series of developmental cycles, but essentially, you were pretty fixed by the age of 16, 20. But what Fisher's work says is that this continues. And he found people developing ways of thinking through this developmental cyclical process, attaining deep understanding of abstract systems and producing new principles even at the age of 28. But he also found people who are stuck at the lower level cyclic plateaus of single abstractions or abstract mappings at the age of 28. So although this is a possibility, and this was a general trend amongst those displaying higher order and lower order thinking, and this was the pattern of development of single abstractions through to abstract mappings of the world, abstract systems where you bring things into relationship with one another, and then the development of principles. He found this is the cycle by which you build up this complex thinking. He found people stuck at the lower levels of this pattern. The good news is you can carry on doing it. This is good for all of us, and we should carry on trying to commit things to memory and carrying on trying to bring them into relationship one with another. Next slide, please. About 15 minutes more now. So it's very interesting in the aims of the national curriculum in mathematics in England, which I led in 2010 through to 2014. You think, well, mathematics is all about mathematical techniques. But actually, the statement of aims in England, which is seen as knowledge-based, wrong. It's very knowledge-based, but it has a huge area of critical thinking and skills within it. Very nice balance between the two. Very similar to Estonia, which is called a competence-based curriculum. Again, wrongly, because it's full of knowledge and committing things to memory, consistent with Fisher's work. What we say in here is that mathematics is an interconnected subject which allows representations of mathematical ideas. The word fluency is used, able to produce things with fluency. Mathematical reasoning, which is linguistic in its character. Increasingly sophisticated problems. This is really good, and language is in there as well. So next slide, please. All of the subjects in the national curriculum include this. So it's true of mathematics, true of science, true of English. The national curriculum for mathematics reflects the importance of spoken language in pupils' development across the whole curriculum. Look at the three terms: cognitively, socially, and linguistically. The quality and variety of language that they hear and speak are key factors in developing their mathematical vocabulary and presenting a justification, argument, or proof. And language is intrinsic to this. It enables you to think about how you're thinking, to express what you're thinking, to understand your mathematical reasoning. Next slide, please. And here it is in Estonia. This false comparison of England as knowledge-based and Estonia as skills-based. It does an injustice to England and to Estonia. Here it is. Mathematics used to understand social, cultural, and personal meaning of mathematics, to formulate problems, analyze solution ideas, test the accuracy of results, giving skills of logical reasoning, justification, and proof, and understanding different presentation methods. Again, language absolutely intrinsic to this. Huge similarities between England and Estonia, even though they're often cast as being at opposite ends of the knowledge skills spectrum. Again, quite wrongly. Don't believe any of that stuff. Right, next slide, please. Right, we're coming to a conclusion now. But there is an issue. How can we explain how we refine our thinking? How can we explain how we develop up that trajectory? And cognitive dissonance appears to play a key role. Of course, cognitive dissonance is an important theory. It's been criticised. We've got to recognise some of the critiques of it. I'll come on to that in a moment. But essentially, cognitive dissonance is a very powerful body of thought which was developed in the early 60s. The idea that it's very difficult to hold contradictory ideas. And what we do in thought is reconcile them. And it's very important, for example, in science, that we have contradictory evidence, which is represented linguistically, and we reconcile it by removing the contradictions. And many aspects of scientific thought, we move forward in science by removing these contradictions. It's resolved by discarding contradictions. If a new word contradicts existing knowledge, its meaning might be discarded. So phlogiston fell by the wayside because it could not explain why some things got heavier when they burn. For example, when magnesium ignites, it actually gets heavier. And that's because of oxidation. It's actually combining with oxygen in an exothermic reaction. And those contradictions led to the development of modern theory, oxidation, and concepts of oxidation. So the way that we develop these networks, which you see in Fisher's representation, so that they become coherent networks, which we can then commit to long-term memory in their own right, is through the removal of contradictions. Now, this is quite controversial, but I'm really positing it as a fundamental mechanism in achieving higher order thinking, and that it has a linguistic component, because in language we develop words which are associated with concepts, and when two words are in contradiction to each other, and the concepts of contradiction are contradictory, we seek reconciliation through cognitive dissonance. And that leads to a new understanding, which we then commit to long-term memory. Next slide, please. So we can see that all of this is consistent with this empirical work of Fisher's. And what we need to do is to help young children progress along this pathway of committing things to long-term memory, things that are accurate, linguistically precise, accurate about the world or accurate about experience. And once they're committed to long-term memory, we can bring them to bear on complex problems through our working memory to formulate new knowledge. This is really powerful stuff and very helpful for what we should be doing in primary school, secondary school, and in higher education, and indeed in professional training. Next slide, please. So I said that I would deal with this issue of decline of literacy because, I mean, I think I am, as you can tell, profoundly committed to the idea that development of language is intrinsic to the development of higher order thinking and sophisticated thought. So it would be worrying, wouldn't it, if literacy is in decline? And I'm afraid there is quite strong evidence that it is. Now, the dotted line represents 1960 in all of these diagrams, and the solid line represents 2011. And this was a very good study for America in terms of the processes involved in reading for comprehension. And what was found is that the rate of reading, silent reading, and think of Fisher, think of the diagram, the more we can commit to our long-term memory, the better. The more that we have varied experiences through reading, the better. But look, the rate of reading is going down, and going down significantly since the 1960s. And goodness me, this is before the digital revolution. I think we can argue that even after 2011 is after the real revolution in reading through digital media. So we've got to do some more research to understand that as well. Fixations per word is how long people actually dwell on a particular word, come back to it in order to understand it. Well, that's gone up. That's a bad thing. Likewise, the amount of time actually spent on things gone up significantly for grades 4, declining, and by the time you get to 11th, 12th grade, it's not dissimilar to 1960s, but they're going back a lot more over things, but they're spending about the same time when they go back over things. That's probably okay, but the fixations per word in the top right-hand side says they're doing it a lot more, and they're doing it a lot more at 11. So it's actually getting worse as they go through education. Again, a very bad sign, actually. And the number of regressions per word, that's crossed over, but again, the total picture here is not good. We want people reading widely, we want them exposed to lots of ideas, we want them reconciling the contradictions, we want them committing it all to their long-term memory. Next slide, please. So we can draw this all together now. And Jane Mellanby's work, which I cited at the beginning, is really fundamental. It's lovely, lovely work with young children. And what she identified was that certain forms of language are essential to higher order thought. They have a logical structure to them. And this one, her empirical work with young people, showed was fundamental. What would it be like if that were not the case? And it's quite complex, rather difficult for a young person to understand, very important in terms of conjecture, whether that be creative conjecture or scientific conjecture. So she identified that language form and then examined it empirically in whether it occurred in education and whether children were able to recognize it and whether they were able to understand the propositions. And you can see how this is linked to thought, because it's quite it elaborates your thinking. You're presented with something real, but you're not asked to describe what you're seeing. You're asked to describe what would be the case if what you're seeing wasn't the case. And you immediately can see how important this is for science, for literature, for social theory, for sophisticated ways of thinking the world, for being a rational and thinking person, not just prone to responding to immediate sensations from the outside world. This is an extremely important form of language. Next slide, please. So what she did was to examine this type 3 language, counterfactual conditionals, and to see how they developed. So from year 1, which in England, children between 5 and 6, up to year 6, children between age 10 and 11 at the end of primary, regrettably what we find is that up to 30% of children either have incomplete or no development of type 3 conditional sentence comprehension. Now, I mentioned Fisher arguing that certain people get stuck at the lower levels of simple representations and lower levels of abstract representations. I believe there's a profound link between Jane Mellanby's work and Fisher's work. What Jane and I looked at was, well, how frequently are children exposed to that form of language? And in certain households, they were not, that form of language was not present in the normal discourse of the home. Now we know that home background explains or is highly linked to educational attainment around the world, with children from more privileged backgrounds doing far better. The exposure to certain forms of language, we think, plays a big role in that. What is being which is being used? Now, schools can compensate for that because they can deliberately use this more complex language. It can be a deliberate object of the curriculum, and you can examine how individuals are progressing in the acquisition of this kind of complex understanding. Next slide, please. So I really want to end on this note. I hope that I've indicated that I believe there is an extremely strong relationship between language and cognition, and that there is strong evidence from the cognitive sciences and from educational theory that there is an intimate relationship between language and thought. I've also argued that as we develop, as we go through education and into life, we can continually support throughout life increasing elaboration of thinking. And we need to do that through language and with the support of increasing sophistication in both the content of language and the structure of language. And so we have a responsibility within education to include certain forms of language, as well as activities which demand complex representations, thought, and application. And so if we are to enhance metacognition and enhance the attainment of young people, we have ready means of understanding through this work what we should do. I hope that that's been helpful, and I hope the fundamental propositions which I started with have been illuminated for you, and that we can go into discussion now in terms of both the propositions and any thoughts that you have. So thank you, Jessica, and thank you very much indeed for attending today.
Thank you, Tim. That was really interesting. And off the back of that, I have a few questions that have come in from the audience. I was going to start with Stephanie's, but actually, based on what you've just said a few moments ago, I have a question from Esther, and they've said, if a person hasn't had the appropriate input at a young age, can they ever develop a higher level of cognition? For example, is there a critical period for cognition in the same way that there is one for language learning? Or they've rephrased it, is there hope for someone who has come late to education or critical analysis, etc.?
Brilliant question, and a really important one practically. One I think which we can illuminate through Jane Mellenby's work, and her lecture on this is on the Cambridge University Press and Assessment website under the Cambridge Assessment Network. Yes, I mean, Jane and I spent a lot of time thinking about this question, and the news is both good and bad. If it's not acquired by the age of 7, it is much harder to acquire. This is the problem. Jane and Julia worked with children beyond the age of 7 who had not been exposed to these forms of language, and found the optimistic and the reassuring outcome. Yes, they could acquire both comprehension and use of these forms of language in elaborating their own thinking, but the bad news was it took a lot longer. And so I believe it's absolutely critical by the age of 7 and essential by the age of 11 to understand what has happened to a child in those formative years. I regret that there's not enough attention paid to this on entry to secondary school, and that we should do diagnostic work with children when they enter secondary school, and they will need protracted and dedicated support, not taken somewhere else for it to be done necessarily, but they will need dedicated and well-structured support in order to develop the means by which they can get to higher order representations. Now, this can be done through things that they enjoy, whether that's leading them through, if they're particularly interested in something to do with mechanical engineering or houses or architecture or flowers or poetry, doesn't matter. As long as what is consciously done is giving them elaborated language in terms of content, the specific concepts, and elaborated language in terms of its form. And if both of those things are done, what Fisher's work tells us is that later development, remember this elaborated process of relating, which you can see in this diagram, is still possible at the age of 28 and beyond. So it's good news and bad news. You have to identify it, you have to attend to it, it takes longer, but it is possible.
Mm. Thank you. So on the back of what you've just said, obviously about the different types of ways you can kind of engage learners, I'm going to go back to Stephanie's question. And the question was around, she says, so if language shapes and influences reality, which kind of language can help students to feel more connected with nature and with other human beings? And I guess what I'm interpreting from that question is around maybe the notion of kind of sustainability, but also to do with empathy. And I think maybe Stephanie's asking for some examples of higher order language that you might want to use in that context.
Okay, great. I think that's a really good question again. I'm gonna quote. I think there's two threads running through the question as well, actually, Jess, and thank you, Stephanie. There is increasing understanding that we need to be highly sensitive to the natural world, and a second strand that we need to be highly sensitive to the social world and the needs and interests of others. And I think I'm not going to reduce it to language, but I think language plays a key role. Dealing with the latter first, the social world and the world of relationships between individuals. One of the big issues, of course, of our time is where people do not understand the mental life of other people. We can see that through international conflict, we can see it through conflict within societies, and we can see that in conflict between individuals. So harmonious relationships can occur where we understand the mental life of other people and are sensitive to them. We don't have to agree with everyone, but we have to understand what they're thinking. And that's where language plays a key role. People maybe, I've heard the phrase, my understanding of economic stability is not the same as your understanding of economic stability. It's a very revealing phrase. So we need to attend to the analysis of discourse between people so that we can understand the mental life of someone else or a group of people. That's critical. And I think, again, all of this illuminates that. By having that kind of engagement, we can understand the mental life of others and resolve conflict. In terms of the natural world, I just quote Mary Colwell, who I work with very closely. You can't really protect adequately that which you do not understand and know. And she says that particularly of the natural world. We have to bring young people into closer relationship with the natural world. Just at the same time that they're saying that previous generations have not cared for the natural world, young people, in saying that we should be much more caring of our environment, much more nurturing of the natural world, they are at greater distance from it. So we certainly made sure we included in the primary national curriculum in England engagement with the natural world, going out there and collecting things and observing things, but crucially naming them, classifying them, and describing them. And this is not trivial. It's in the national curriculum. It's going out and finding 5, 6, 10, 20 leaves, seeing that they are different, explaining why they are different, classifying them, having concepts to describe them, and by doing so, developing not only an understanding of the natural world, but an emotional relationship with it because it is understood better. So I think all of this is really essential. And goodness only knows, climate science is complex. You need to have an understanding of concepts like negative and positive feedback. You need to understand that it genuinely is worrying that we can see more of the Northern Ocean and see that it isn't ice, because ice reflects solar radiation, whereas the open sea absorbs it, and as the ice melts, more energy is absorbed, so the ice melts faster. You need these understandings to be a responsible citizen and to be someone who cares about the ecology of the planet. So really, I think the things I've been emphasizing about conceptual understanding and the provision of complex language is fundamental to both this awareness and engagement with the natural and social world, which your question has highlighted, Stephanie. Thanks, Jess.
Thank you for that. That's really useful. Just while I'm scanning for some more questions, I had a question about, obviously in your presentation, you mentioned about learners and the importance of language in those early years, and how school can have a massive impact on developing language and on kind of promoting higher order language and then higher order thinking. But I wondered if you could comment a little bit on maybe comments that school, because it is a middle class habitus, might actually serve to maintain like a status quo of keeping people in their place. And I wondered if you could comment on that in terms of language and the relationship between that.
Yeah, absolutely. And I think, again, I'll highlight two things. I think when we did the National Curriculum Review in England, which was informed very much by international comparisons, we looked at the occurrence of technical terms in across all languages, across all subjects rather, at what age they occurred, and where it was expected, that a child would have mastered a particular term. And I became quite concerned, Jess, that exposure is not well represented in national curricula. And by exposure, I mean this, that most national curriculum, and almost all nations now have got national curriculums, think that they're really lists of things that people need to have learned by a particular age. And regrettably, quite a few systems, including England, the assumption is that it's not. People don't think that that's when you need to demonstrate it. They think that that's when you need to teach it. So if something appears as a requirement for 14-year-olds, well, you teach it at the age of 13. But the work that I've done suggests quite the reverse, actually. They need to demonstrate it at the age of 14, but they need to be exposed to it much, much earlier.
Absolutely, yeah.
So when you talk about the extent of middle class habitus and I referred earlier to the impact of home background, what you will find is certain kids will be exposed to language, like concept of oppression, for example, or authority or corruption at a much, much earlier age than others in the context of their home environment. And as a result, when they experience it for the first time in education, perhaps at a much, much later time, they're familiar with it and they can elaborate it. They can bring it into a relationship with other things. And we identify all of that as high attainment.
Yes.
But if only we'd spoken about these things with all kids in school earlier. So you see, I think that's really, really important to break this relationship between the home and school, so why school is so important. I often, by the way, use exam questions for 16-year-olds with 8-year-olds. I don't expect them to give me the kind of answers I would expect at 16. It exposes them to the ideas and stimulates their thinking. Now, your second point was, well, is this all about the reproduction of existing social relationships and so on? Well, that's an interesting one, because the earlier you introduce children to an idea like power, for example, an authority, then the earlier they can begin to see it in the outside world and to criticize it.
Challenge
this
it,
is something
absolutely.
And this is what Michael Young and I are very committed to, powerful knowledge. Because you can get them into this slide that we've got in front of us, you can get them into the development of these sophisticated arrays much, much earlier. So school then becomes part of the creation of a new reflective critical society. One in which there is innovation in thought and scrutiny of thought, so that school doesn't just become a passive reproduction of existing social arrangements.
Absolutely, and I think that you kind of touched on that as well when you talked a little bit maybe about the decline of literacy, in the sense of maybe the literature that children are able to consume. And I as an ex-English teacher, I obviously think a lot about like the literature curriculum, but also about the books that children can read, and how, as you were talking, I was thinking about, well, yes, if a child reads a storybook, you know, from a very early age, and there's a horrible kind of person in power, that can be a really interesting discussion for them to then think about why the actions of the person was wrong, and that development through the language of the story, but through their own language as well, can be interesting. A question's just come in about risk of letting students see the dynamics of power and authority. We've only got 3 minutes, but
I'll be very quick.
I don't know if you want to comment on that.
Thanks, Jess, I will do. Yes, I mean, I recognise absolutely that in different nations around the world, there is a different propensity for schooling to be critical or not of the outside world and society. I understand that absolutely. The biggest danger, by the way, is if you don't expose children to concepts like power and authority, they become prone to ideology. And that is worrying. I mean, I'm not arguing here for the politicization of education. Absolutely not.
No.
I'm arguing for development of the highest level of critical thinking at the earliest possible age, where people can contribute to the further development of society. You know, all societies undertake development. No society is in stasis. No society stays the same, by definition. And so what we want is for young people to be able to participate in a constructive and appropriate way within creating a more harmonious, more effective, more productive society, where individuals stand in good relationship with each other, and segments of society and nations stand in good relationship one with another. So, Jess, I mean, thank you, and it's been a great opportunity to discuss these things.
Yeah, absolutely. That took a turn that I kind of wasn't expecting us to discuss in the conversation, but thank you very much for answering those questions and for the presentation as well. We've had a really good response here. So if anybody has any further questions, you know, we can pick those up again in the workshop panels later on in the weeks. But thank you everybody for your contributions today. And again, thank you so much, Tim, for such an excellent presentation.
Thank you all, and thanks everybody for attending. It's been really good.